All right, problem 3, solving a 3-variable system. Use whatever method you want, but show all your steps. All right, so the idea here is we need to combine our equations in ways to eliminate some variables. So easiest way to do that right off the bat, I believe, is to combine the top equation and the middle equation, add them together. 3x plus 2x is 5x. Y plus negative 2y is negative y, and a negative z and a positive z cancel each other out. 3 and a 7 gives us a 10. Now, I have an equation with x and y, which means I now want to get another equation with x and y. Fairly straightforward to do that using now the bottom two equations. But I need to multiply the middle equation by 2 first. So I'll need 6x plus 2y minus 2z equals 14. Now I can combine that with an x minus 3y plus 2z, and my z's will cancel. So let's add that together. 6x plus x is 7x. 2y minus 3y is negative y. And finally, a negative 2z and a positive 2z cancels, and we're left with 14 on the left. So now I'm going to combine these two equations in x and y. And I need to subtract one from the other, but think of that as multiplying by a negative 1, so change the sign of all the terms. So now I can get a negative 2x, negative y and positive y cancel each other out, and I'm left with 10 minus 14 is negative 4. So that tells me that x equals 2 when I divide by negative 2. So I know x, which means I can now find y. So I have 5x, which is 2, minus y is 10, using that equation right there. So notice I have 10 equals y plus 10. I added the y over, which means subtract 10 from both sides, y equals 0. Let's use an equation to find z. Top equation should be fairly easy to use. 2 times x, which is 2, minus 2 times y, which is 0, so it doesn't do anything, plus z equals 3. So we get 4 equals 4 plus z equals 3. So then z equals, subtract 4 from 3 to get negative 1. So I've got x is 2, y is 0, and z is negative 1.